Okay, we're going to graph this nonlinear inequality, and for reference we will see note number 46. Okay, so this thing is a strange graph. Now, we do have that as one of our basic fundamental graphs. It's true. So we know that y equals x cubed is sort of a snake-like picture. It sort of looks like this. Okay, and it's just a rough idea. We want to be a little more precise than that for this graph. That's with the equal sign, by the way, not the inequality sign. So to be a little more accurate, we can do a couple of ordered pairs, x, y. Plug them into x equal y cubed. When x is equal to -1, y is equal to -1. When x is equal to 0, plug it in, and you get y equals 0. When x is equal to 1, y is equal to 1. Okay, so we also notice that the original inequality symbol looked like this. It had an equal portion, so that implies that our graph is going to be what? Dotted or solid? Solid. Solid graph because it contains the equal portion. Okay, so let's go ahead and do that graph. So we've got the points 1 and -1, 1 and -1. So we have a point at 1, 1, 0, 0, -1, -1, and we have the shape that we have up there in the cloud. It looks like this, goes to the origin, comes back around. Basically this picture. And it's a solid graph. Now, because this is an inequality that we're graphing up here, it's an inequality, we must test a point to decide where to shade it. Test the ordered pair xy equals, well, we cannot test 0, 0 because it lives on the graph. That's not available to us, so we're going to have to try a different one. Why don't we choose, well, how about testing the point, what is y equal to when x is 2? Go back up here. When x is equal to 2, plug it in, y is equal to 2 cubed, which is 8. Okay, so that's a point that's on the graph. So let's test the point 2, 1. That's this point here. This is our test point. You see how it lives off of the graph. So we're going to test the ordered pair xy equals 2, 1. And we have to name our test point. That's required. Now show the test. That's another thing that's required. The inequality was y greater than or equal to x cubed. So let's plug in our x and our y. 1 for the y, greater than or equal, question mark, to 2 cubed. Is 1 greater than or equal to 8? No, it's not. It failed. And if it fails the test, if our test point fails to satisfy the inequality, we are required to shade the opposite side. Okay, so remember the test point? It lived over here in this dotted area. That means that we are shading everything on the opposite side of this graph. And every ordered pair that lives in this shaded region is an ordered pair solution to the inequality. And we are finished.